Understanding Eulerian and Hamiltonian Path. Leonhard Euler, he is a mathematician who invented the Eulerian path. So what is an Eulerian path? An Eulerian path, or a Euler path for short, is a path that uses every edge of a graph without any repeats, and it can start and end at different vertices. This example here shows an Eulerian path or an Euler path. So we start at vertex S to vertex T, then vertex T to vertex A, then vertex A to vertex R, and finally vertex R to vertex T. An Euler circuit is a circuit that uses every edge of a graph without any repeats. It must start and end at the same vertex. So an example of an Euler circuit is drawing a star. In drawing a star, we start from vertex 1 to vertex 5, then vertex 5 to vertex 9, then vertex 9 to vertex 3, then vertex 3 to vertex 7, and finally vertex 7 to vertex 1. As you can see, we start and end at the same vertex, which is the vertex 1. Tips in identifying whether the graph has an Euler path or an Euler circuit. So if a graph contains at most 2 vertices of odd degree, it is considered as an Euler path. If all vertices of a graph have even degree, it is considered as an Euler circuit. Let's find if this graph has a Euler path or a Euler circuit. To find if it is a Euler path or a Euler circuit, we must find the degrees of each vertices. So vertex Z has 2 degrees, vertex H has 3 degrees, vertex C has 2 degrees, vertex D has 4 degrees, vertex K has 3 degrees, vertex V has 2 degrees, vertex E has 2 degrees. In this graph, it shows that there are 2 odd degrees, which are vertex H and vertex K. So this graph shows an Euler path, not an Euler circuit. Now let's find a Euler path. To get a Euler path, we first have to start at K to V, then V to E, E to K, K to D, D to C, C to H, H to Z, Z to D, and finally D to H. Here's another example. W has 2 degrees, B has 4 degrees, O has 4 degrees, L has 2 degrees, F has 4 degrees, E has 4 degrees, and D has 4 degrees. Since all degrees are even, this means that the graph is an Euler circuit. Now, let's find an Euler circuit. First, we start at D to B, B to F, F to D, D to E, E to F, F to O, O to E, E to L, L to O, O to B, B to W, and finally W to D. In this graph, there are 4 vertices, which shows odd degrees. So it cannot be called an Euler circuit. To be considered as an Euler path, it must have at most 2 odd vertices. Since this graph has 4 odd vertices, it is not an Euler path, neither an Euler circuit. William Rowan Hamilton, he is the one who invented the Hamiltonian path. A Hamiltonian path is a path that uses every vertex of a graph without any repeats. It can start and end at different vertices. The difference between a Hamiltonian path and a Euler path is that the Hamiltonian path uses every vertex of a graph, while an Euler circuit uses every edge of a graph. Okay, here's an example of a Hamiltonian path. We have to start at K to Y, Y to U, U to M, M to J. Notice that we did not use all of the edges in this graph, we didn't use the line J to U and U to K. A Hamiltonian circuit is a Hamiltonian path that starts and ends at the same vertex. Here's an example of a Hamiltonian circuit. First, we start at S to D, then D to N, N to L, L to X, X to S. As you can see, we start and end at the same vertex. Okay, let's find if this graph shows an Hamiltonian path or a Hamiltonian circuit. So, if we start at vertex L and transition to D, then D to Q, Q to O, O to E, E to F, F to C, and finally C to K, we get a Hamiltonian path. But if we start with L to F, F to C, C to K, K to E, E to O, O to Q, Q to D, and finally D to L. This shows a Hamiltonian circuit. So this graph has both Hamiltonian path and a Hamiltonian circuit. Now let's try another example. If we start with T to R, R to W, W to X, we get a Hamiltonian path. As you can see, we can't get a Hamiltonian circuit because we can't start and end at the same vertex. So even if we start at vertex W, then to X and X to R and R to T, we can't go back to W. Or if we start with T to R, R to W, W to X, we can go to X to T. So this graph does not show a Hamiltonian circuit, but a Hamiltonian path. Now let's apply a Hamiltonian path or circuit in this scenario. A delivery man has to deliver 3 packages to 3 addresses. After delivering the 3 packages, he needs to report back to his superior. Which circuit should he take to deliver the packages with the least amount of time used? Now we have to construct a table and put all of the options there. So here we have 3 options. And next we have to list down all of their weight. Option 1 takes 18 hours. Option 2 takes 11 hours. Option 3 takes 13 hours. As you can see, option 2 takes the least amount of time, so the delivery man must choose option 2. In option 2, it is fine if you reverse the order. So if you start from the company to the blue house, then the blue house to the orange house, then orange house to the red house, then finally red house back to the company, you still get the same time used, which is 11 hours. Thank you for listening.